So in the last lecture, we had been looking into the D-Latch circuit, and as we still recall that a latch is a sequential device that is level triggered. And if I again repeat what is meant by level triggered is when the level of the clock is set to logic high, that is the time when the input is copied to the output, and if the clock value is set to low level or logic low, it is disabled. So the input may change, but that input is not going to be reflected on the output of the latch. Okay, that is something that we need to remember. And suppose we were using this clock input as a write enable input. So this is write enable, which basically means if the write enable is set to 1, the data is going to be copied to Q, and if the write enable is set to 0, the data is not going to be copied to Q. Okay, so it is just going to retain its previous value. Okay, and then we discussed what if we replace this clock enable or connect a clock to the write enable input of the D-Latch. So as you can understand that a clock pulse is going to have a sequential alternative open and closed inputs, which is logic high and logic low. You can always see the square pulse that is shown in the diagram number 1 on the top. This is your clock input, and this, if you look at this as the amplitude, this is your logic 1 and this is logic 0, and this x-axis denotes your time. So as time flows, as you can see, the clock input goes from 0 to 1, it stays temporarily at the value of 1 and then again comes down to 0. So we have discussed all these things in a set of previous classes where we talked about duty cycle, frequency, time period, and so on. Here we are interested in looking into the timing diagram of a D-Latch. So here, as you can follow, that let us consider this as the timing input or the clock input on the top. Next is the data. This is your D, and as you can see, the data could be provided anytime, just that it is going to be transferred to Q if and only if the write enable is equal to 1, right? So as you can see that this portion of the figure that I am marking with red, D's value should be reflected in Q, okay, because at this time write enable was set to 1, right? So if you can see this portion of the clock period, which is this clock cycle denoted by 1, D was copied to Q, but immediately after that D although maintained its value, and but the clock became 0. So let's say this is segment number A, and the next clock is like basically segment number B. Just for our discussion for the time being, we are calling is the next segment. Okay, so now if you see this value was continuing till some point and then it changed. Okay, it's changed. So I can use another color for the next clock. If you see, I am putting now a blue color, right, for the data in the segment number B. So if you follow the value that is coming to Q, because B, for the B segment the clock is off, so the clock or the write enable is off, which basically means that D should not be copied to Q. If there was some value that has already been written to Q, that will be retained. Okay, so see, at this point in time, at whatever time this is, the value of Q is set to 1, and so whatever happens in the D, it is not going to change its value till the next clock pulse. So even if there was a change here, right? So this is a change in D. Although there was a change in this value of D, this is, I would say, not reflected in the value of Q. Okay. So this is not reflected in the value of Q. When does it get reflected? It gets reflected only in the next clock pulse. Whenever, let's say this is considering segment C, right? C, here your clock is on. Okay. So if the clock is on, because the value of D is now 0, this will update the value of Q here. So this value of D is now 0, this is set to 0, this was 1. So for this particular period, Q updated to 0. Okay. So this is how this D-Latch works, and I kind of re-explained you the timing one more time in a little bit of more details. And as you can understand, it captures the input when the latch is enabled, and or otherwise it will hold the previous state whenever the write enable is closed or the clock input is level 0 or logic 0. Okay. So one important thing that you should understand here is this: all these things are asynchronous, which means that D can change itself without paying any attention to how the clock moves, right? The clock could be moving at its own pace, and doesn't matter, the D can change its value in the middle of a clock, in the beginning of a clock, at the end of a clock, doesn't matter, right? So it is completely asynchronous. Okay, it is not synchronous. The value of D is not going to be synchronized to the triggers of the clock, right? Or whenever the time the clock goes from the low logic to high logic or high logic to low logic, it has nothing to do with the timing of D. D is your data or the input. Okay, so that is about the D-Latch timing. As you can understand that it has these asynchronicity issues, and the levels are kind of respected here. If the level is only high or the level is low, at that period of time, for that period of time, the input and output has to be copied. I mean, the output has to be copied from the input. It depends also on the time period till which the clock is on. So the time you are copying the data from D to Q also depends on how long is this particular clock input high, and because of variety of reasons, there is no guarantee that the clock input is high for the exactly the same amount of time in all cases, right? So there will be some amount of randomness or some amount of lack of precision in the amount of or the duration of time the clock is high. So if you are doing a level triggering, that you are only going to copy the data to Q when the clock is high, sometimes there are timing issues are also introduced. So there are some timing related discrepancies show up. So whatever is the length of the segment for C may not be exactly equal to the length of the segment of A, right? So whatever control input or whatever input you are actually passing, that is also supposed to change, and because of this asynchronicity, there are timing related issues that might happen. Okay, so to clear this confusion, we have this concept of flip-flops, which is no longer a latch, right, but edge triggered device, okay, or edge sensitive device often it is called. So if I draw the clock one more time, the clock looks something like this. You have a high pulse followed by a low pulse, low logic, then again a high, again a low, and so on, right? Dot dot dot. So for a level triggered device, I can see that you are only going to be on for some specific periods of time. That is what I am marking by red, or this, or this. This entire period of time, this is going to be on. This is for a latch. So on or write enable. Whereas in case of a flip-flop, what we do is that we, instead of looking at the level, we actually start looking at the flips from 0 to 1. So if you think of this as the low level and this is the high level, so this is the only flip that we consider. So this is the edge of this clock. That's why we call it edge sensitive. So this edge could be a high to low edge or a low to high edge. For most of our discussions, we are going to restrict ourselves to one kind of an edge, which is low to high. So this is low, this is high. This is a low to high transition. And if there is a low to high transition, we call it a clock edge, and we are going to trigger the data transfer. For example, in case of a D-Latch, we were transferring the data from D to Q. If we are trying to create a D-Flipflop, we are going to transfer the data from D to Q only when we see a low to high trigger. So this is also going to happen here. So this is the next time this thing happens. Next time this thing happens is here. Okay. So instead of 3 level changes, we have 3 edge triggers. Okay. So this is a particularly beneficial compared to the level triggering with respect to timing, because at least even if you do not have the high period or the low period of the clock exactly similar, but the trigger is much more instantaneous, right? So the trigger, whenever you have an event of a trigger, then only you copy the data from D to Q. It does not depend on the exact timing. So the timing related discrepancies are less probable here. Okay. So this is a more robust in terms of this implementation. Okay. So the D-Flipflop, how it is going to be constructed, I am going to show that in the next slide. So instead of using one D-Latch, the trick is to use 2 D-Latches back to back with a clock and a negated clock. We are going to show that soon. The configuration makes sure that the circuit is edge triggered. Okay. So otherwise it retains the value, right? When the clock is steady at 0 or steady at 1, or even it is changing from 1 to 0, right? Unless and until you have a dual trigger, because typically the others, like let me draw, let's say this part, right? So this part is another edge. So this is high to low, or this part, this is another edge, right? This is high to low. Okay. So there are flip-flops that are called dual edge triggers, right? That are going to trigger at both low to high as well as high to low. Or we can have only one kind of edge triggering. Either it could be low to high, or it could be high to low, right? Both of them may be present, or one of them may be present. In our case, we are considering this. We are considering low to high trigger. In that case, this will be ignored, right? So if this is the case, or if it is stuck at 0 or stuck at 1, in those cases we are not going to do any data transfer. So now this slide shows you the structure of a D-Flipflop, which has 2 successively attached with each other, 2 D-latches. Okay. So the first one is the latch, which is often called a master in this configuration. We will come across a few types of flip-flops that has a master slave configuration. The first one is typically called the master, and the next one to which the output is associated or output is connected is called the slave. Okay. So as you can see, the trick is to use a negative clock, right? The clock that is going to one of the D latches and the clock that is going to the second D latch, they are inverted in the polarity, right? So if it is high for L1, L1 is the latch number 1, it is going to be low for the L2, right? So if you see the clock, let's say this is the clock, this clock is going to be exactly opposite. Okay, and for this is going to be the input to latch 1, and this is going to be the same as the input. Okay, so this kind of a configuration, and one more thing, that there is a forwarding of the output of the first D latch into the input of the second D latch. Okay, so if you analyze this configuration, you would be able to understand that this clock, or sorry, this configuration or this circuit is going to transfer the data from D to Q only at a positive edge of the clock. Okay, or at least at the edge of the clock, that you will be able to understand. So this is kind of important, that once this thing occurs, or once this thing occurs, at that time only D is going to be copied to Q, otherwise not. And this configuration is typically called a master slave configuration, and here we are using D latches to create a flip flop, so it is called a D-Flipflop. Okay, so now if we look at this table, the table indicates that what is the value of the clock and what is the value of the output, the next output once you pass the clock, right? So as you can understand, it is not different than what a D latch was. A D latch was primarily copying the data from the input to the output. If D is equal to 0, the next value of Q would have been 0. If D equal to 1, the next value of Q would have been 1. But here it is conditional on the value of clock. Okay, so D is 0 and Q next is 0, fine. D is 1 and Q next is 1, fine. But this is conditional on a low to high trigger. Okay, otherwise if you have clock is equal to 0 or clock is equal to 1, it does not matter. The value of D doesn't matter. Okay, the value of D doesn't matter. Q next is equal to your previous Q. So the value of Q did not change. So Q next is the new state of Q after triggering clock edge occurs, the rising edge. Okay, so this is also called a rising edge. So this is your low, this is your low, this is your high. This is called a rising edge. And the other way around, if we do, this is called a falling edge. This is high, this is low, this is called the falling edge. Okay, so this is about your master slave configuration in general. In general, we are going to look at another master slave configuration, and this is an example of the D-Flipflop. Okay, this is an example of a flip-flop, namely D-Flipflop, which was made using 2 D latches. So if you look at the timing diagram now, so the first one is the original clock input. This is the original clock. Then you had clock 1, which is the reciprocal or the inverted version of the input clock. Then you have clock 2, which is same as the original clock, inversion of clock 1. Then you have D. Okay, D is still it can come at any time, right? D is not synchronized with respect to clock, but we need to make sure that Q follows some rule, right? So the Q, as you can see, has to follow that whenever there is a rising edge, at that time only you are going to copy the data of D into Q. Okay, so QL1 is, as you can understand, that QL1 is pretty much, this is a latch output. So QL1 is level triggered. Okay, so QL1 depends on the write enable input of the first D-Latch. Okay, so when clock 1, as you can see, the clock 1 is high. This is the time the clock 1 is high. The value of, this is the value of D, this is the value of D, and this is the value of QL1 with some delay, because there will be some gate delay. These values are copied, and whenever the L2 L1 is closed, the QL1 retains the value. Okay, and so on, right? So again later this is open, so at this period of time the L1 is again open. So at that period of time QL1 is again, as you can see, is again copied here. Okay, and so on. And so this is still the first part is still a level triggered device because it's a D-Latch. The next one is a inversion of the clock 1. So this is clock 2. Okay, so when this clock 2 is fed to L2, the output is going to be Q, but the output is only going to be copied or transported from QL1 to Q only when there is an edge. Okay, so that will require you to understand that there are two NOT gates. So if you just draw instantaneously, for example, the clock, so let's say this is clock 1, the clock 1 may look like this, and I will draw also clock 2, CLK clock 2, maybe with a dotted line. Right, so if you look at these two, I am giving the value of QL1 at the rising edge of the clock, right? So at the, not the rising edge, sorry, the high level of the clock. So for latch 1, so for latch 1, as you can see, there is no data at this part. Only whenever this is a high value, the data is going to reside. Okay, so QL1 is going to be active, but QL1 is only going to be copied to Q, right, whenever the value of clock 2 is also high, right? Otherwise it is not going to be copied, right? So here you can see that there is only this period of time whenever clock 2 is high, right, as well as you have the value of QL1 written from D, right? Or as you can see here, this is high, right? So this is basically going to give, intuitively you can understand, these are the edge triggers. Okay, so clock 1 is going to be high, it's almost done because it's a NOT function. So although they are not instantaneous, there will be some delay involved, and that is what gives rise to an instantaneous edge. There is a very small period of time when clock 1 goes from 1 to 0 and clock 2 comes from 0 to 1, and that is the time when you have an edge, when you have a rising edge, and that rising edge is the amount of time or the window of opportunity when QL1, which is basically some kind of a D2, because this is the data for the second latch. If I call it data 1, D1, okay, so D1 is always copied to QL1 or QL, the first output, and only in the rising edge QL1 is going to be copied to Q. Okay, so understand, or you can reflect on how this is working. I kind of give you an idea intuitively how this works.